Okay, welcome back to the second half, and I already record the the second half, and let me share the screen. Okay, before this, from the beginning of today's class, we have a long derivation, and it requires imagination, and maybe you need to take time to reconsider, to check, like carefully check step by step in order that you understand the derivation and the concept. But from now, the application of using the rotating axis, from now, the step by step is straightforwardly, and you can apply it to the problem, and it's not that difficult. And let's check the problem together. What happened here? We have the link CB. The link CB is rotating counterclockwise with the constant rate n 4 radian per sec. And on the link CB, we have a pin at point A. We have a pin at point A. And this pin traveling in the slot DE. Traveling in the slot DE. And when the link CB rotate counterclockwise, when the link CB rotate counterclockwise, it make the part ODE. It make the part ODE rotate clockwise. Rotate clockwise. It seems like when CB rotate counterclockwise, the pin A travel along the slot, and it may increase the radius. And when it increases the radius, it causes the ODE to rotate in the clockwise direction. And the problem wants us to find the angular velocity and the angular acceleration of the part ODE. We still don't know the direction of the alpha, but in this case, they said omega omega of the ODE is clockwise. Alpha we still don't know, but yeah, just assume alpha to be clockwise also. And when we obtain the numerical value, if it's negative, it means the direction is wrong. And let's begin. The problem give the omega of the link CB is 4 radian per sec in the counterclockwise direction. In the counterclockwise direction. And what we need to find, we need to find the omega of ODE. And the direction is given. It should be positive. If we're gonna assume the omega in the clockwise direction and to be positive. And for alpha ODE, we also gonna assume it to be positive in the clockwise direction. But if we solve the problem and we found the negative value for the alpha, just remind that the exact direction should be on the counterclockwise. And what should we do for this type of problem, when we know nothing and we need to begin, but we understand how the system moves, we try to define the variable need for solving the problem. Then the next step is to write down the governing equation. For the speed, the relative velocity, the governing equation is velocity vector of point A can be related to the velocity of the reference coordinate, the rotating reference coordinate. And in this case, we're gonna set the rotating reference coordinate at the center of rotation of the link ODE, of the part ODE. So the velocity is the velocity of point O. We're gonna consider the X and Y at the point O. And if you remember the relative velocity, we have the velocity of the origin of the frame. We have omega crossed by the position vector, the relative position. And we consider the relative velocity. What is the VA? Do you think we can obtain the velocity vector of VA from the information given by the problem or not? We know that the link CB is rotating clockwise, counterclockwise with the constant angular velocity. So the velocity of point A, the velocity of point A of the pin is equal to the omega of the link CB. Omega of the link CB. And crossed by the position vector measured from the point C to point A. The velocity vector at point A is the omega of CB crossed by the position vector from C to A. So omega of the link CB, magnitude is N 4 radian per sec, the magnitude of the omega of the link CB. And the direction of the omega, link CB rotate counterclockwise, link CB rotate counterclockwise. So the direction of omega is positive K. And what is the position vector from C to A? The position vector from C to A. The distance from C to A is 0.12 meter. The direction from C to A is negative Y direction. Negative Y direction. So by obtaining the cross product, Kj will be minus I, right? Kj will be minus I, but we still have minus here. So we have 0.48 I. K cross J is minus I, and we have minus here. So it's gonna be the positive one, and the magnitude is 0.48, direction I. Do you think it makes sense if we see in the picture, the link CB rotate in the counterclockwise direction? Do you think it makes sense that at this position, VA have only the I component to the right-hand side? Yes, it makes sense. How about the velocity of point O? How about the velocity of point O? Point O doesn't move. Velocity 0. How about omega cross R? Omega for this one, omega cross R is omega of the frame XY. The frame XY is attached to the part ODE. Omega is omega of the part ODE. What is the direction of the omega of the part ODE? The problem said that omega of the ODE is rotated in the clockwise direction, which means the magnitude and multiplied by the direction, the clockwise direction. In this problem, we set X and Y direction here. So if it rotates clockwise, the omega will have the minus K direction. Minus K direction. And the position vector, the relative position vector, the position of the point A with respect to the origin of the frame X and Y. The position vector in this case is 0.12 in the I direction. We measure from the origin to the point A position along the positive X direction with the distance 0.12 meter. So K cross I will be positive J. K cross I will be positive J. And we have minus 0.12 omega ODE and Kij direction. How about the relative velocity? The relative velocity. The relative velocity with respect to the frame X and Y, we don't know how fast is the point A, pin A, move along the slot. We don't know, but we don't know the magnitude of the relative velocity. We don't know the magnitude of the relative velocity. And we don't even know the direction, if it's gonna point to this direction or point to the opposite direction. But by the geometry of the slot, and we attach the frame X and Y on the part ODE, we can form the relative velocity in the vector in the terms of the magnitude multiplied by the direction of the slot. The direction of the slot we have cosine 45 degree I and sine 45 degree J. The slot is fixed on the part ODE, and we attach the frame X, Y, I, and J on the part ODE. So the definition of the slot on the coordinate frame IJ never change, but we just don't know the magnitude and the direction of the relative velocity. What should be, if we consider the x-axis, from the vector equation, we have 0.48 to the left hand side, and to the right hand side we have 0, and this is also 0 for the x component, and the last one is relative velocity cosine 45 degree. What is the magnitude of the relative velocity? What is the magnitude of the relative velocity? It's just 0.48 divided by cosine 45 degree. So the numerical value, and it's positive, which means the direction that we assume to be this direction is still true. What about the y component? The vector equation in y component, the VA doesn't have the component in the y component. So on the left hand side is 0. On the left hand side is 0. To the right hand side, V0 is 0. Omega cross R is minus 0.12 omega ODE. That is still unknown and has the negative J direction. The last term is V relative multiplied by sine 45 degree in the positive J direction. So can we solve the equation? We know the V relative, right? We know the V relative from here, and we know the angle. And by solving the equation, the magnitude of the omega, is equal to 4 radian per sec. And it's positive, which means the direction that we assume to be clockwise direction is true. If we want to answer as vector, the clockwise direction is gonna be minus k. So now we obtain the omega of the part, and in the next step we need to solve for the angular acceleration, alpha. Again, begin with the governing equation. Acceleration of point A can be related to the origin of the frame at point O. And the angular acceleration, the centrifugal, the Coriolis, and the relative acceleration. The alpha, the centrifugal, and the Coriolis, and the relative acceleration. What is the acceleration of point A? What is the acceleration of point A? We may consider like we have acceleration of point A in tangential direction and acceleration of point A in normal direction. For example, point A, we have the velocity. We have the velocity of point A 0.48 I. Velocity of point A is in the horizontal direction. You may, if you still remember, if we put NT coordinate, NT coordinate now correspond to the XY of the moving frame. NT coordinate now correspond to the XY of the moving frame. The tangential and the normal acceleration, if the link CB rotate, with constant angular velocity n, the tangential acceleration will be 0. But the normal acceleration, if you remember the normal acceleration in this direction, it will equal to omega square multiplied by the radius from C to A. And the direction of the normal acceleration will be in the J direction. So omega CB is 4. And the radius from C to A is 0.12 meter. And the numerical value is 1.92. This is the acceleration of point A that we obtain from the information of the rotation of the link CB. Acceleration of point O. Point O is fixed. Acceleration 0. What is alpha cross R? Alpha is the alpha of the ODE. And we still don't know the direction of the alpha, but we assume the alpha to be positive in the clockwise direction as the omega. So if we write it in the vector form, the direction of the alpha will point in the negative k direction. Negative k direction. So minus alpha ODE in minus k direction. This is alpha. How about the relative position? Relative position from the origin of the frame xy to point A, to the point A, will be 0.12 in I direction. IJK, K cross I, K cross I will be J, but we have the negative here. So minus 0.12 alpha ODE K, no, J. How about the third term? Omega cross R. Do you still remember the omega of ODE? Omega is minus 4K. Omega is minus 4K direction cross minus 4K direction, and R is 0.12 in I direction.
นี่คือเส้นไหนเหรอครับ
R is the position vector point from the origin of the frame xy to the point A that we consider is from here to here, and the distance will be 0.12, and the direction will be in positive I direction. Okay, the first group here, K cross I, K cross I will be J. So K cross I will be J. So we have minus 0.48 Kij. And finally, K cross J, K cross J will be minus I, and minus 1.92 I. The next term, the Coriolis term, the Coriolis 2 omega cross V relative. The Coriolis term omega minus 4K relative velocity. The magnitude of the relative velocity is this, and the direction in I and J is this component 0.679, and cosine 45 degree I plus sine 45 degree J. Okay. K cross I will be J. K cross I will be J. K cross I will be J, but we have the minus. So minus X multiplied by 0.679 multiplied by cosine will be J. And K cross J will be minus I. K cross J will be minus I. And we have minus, so it's positive. Okay, the relative acceleration, the last term, we use the same method, the same way. With the relative velocity, we just want to find the magnitude because we know the direction. The relative acceleration is the magnitude and multiplied by cosine and sine. And in x-axis, in x-axis, we have 0 for the left hand side. For the right hand side, in x-axis, we have minus 1.92, and we have 3.84, and we have relative acceleration multiplied by cosine 45 degree. And by solving the equation, we have the magnitude of the relative acceleration, but it's minus. It means that we assume the relative acceleration to be in this direction, but it's minus. So the actual direction, acceleration of point A in the slot, is in the opposite direction. How about in the y-axis? In the y-axis, on the left-hand side, we have 1.92. On the right-hand side, we have minus 0.12 alpha. And this one, minus 3.841. And the last term is the relative acceleration multiplied by sine 45 degree. And by solving the equation, we know the A relative, right? We know psi, we know everything. and we can solve for the alpha. For me, I have the negative value. You can cross-check the number for this step and this step. I have the negative one, which means in our assumption, we assume omega and alpha to be positive in the clockwise direction. So the numerical value is -1. So if you're gonna write the vector form of the alpha, it's gonna be in the counterclockwise. In the counterclockwise means positive k. So yes, yeah, we done all the example for today. In next week, we're gonna continue with some example for the rotating axis, maybe more 3 to 4 example, and then I'm gonna pass the class to Ajahn Lim to have the assignment, the term project assignment. And today, as I mentioned in the beginning of the class, that we gonna review one more example from our last class that we still hadn't completed. I'm not sure if some of us spend time to try the example. In the previous week, we tried to solve this problem using the ICZV method. And it's very simple to use the ICZV method, but we need to understand the picture. And for the ICZV, if you remember, please review in the video for the ICZV technique, but we begin with, we know that at this point it moves up and down. So when this part moving to the right hand side, the velocity vector of B is to the right hand side, and for the D, the velocity vector is point downward. And the idea for the ICZV is we draw the perpendicular line to the velocity. We draw the perpendicular line to the velocity. And at the intersection point between the perpendicular line, it's gonna be the ICZV point, and we apply the idea, like we try to use the given information to obtain the omega of the omega about the ICZV, which is the omega of the link ABD. Because when we obtain the ICZV, we draw the velocity of point D, velocity of point B. The point B and D are on the link ABD. So the omega that we have will be the omega of the link ABD. and we can obtain what the problem wants. They want to know the velocity vector of the point A. By use the relative motion method, in the early of last week class, last week we have relative motion method for the translating axis, and then continue with the ICZV. And now we're gonna review the relative motion method using the translating axis. And in this problem, the problem gives the information. The problem gives the velocity. The plunger, this one, has velocity of 2 meters per second to the right-hand side. So they said that the plunger moved to the right-hand side with 2 meters per second, which means we know the velocity, the horizontal velocity of the point A. We know VAX equal to 2 meters per second to the right-hand side. And we know at this position, the theta is 30 degrees. Theta is 30 degrees. What we need to find? We need to find the downward velocity. The downward velocity of the roller at point D. And we need to find the angular velocity omega of the link ABD. So we need to find the downward velocity at point D. And we need to find the omega ABD. The solution by using the relative motion method. Let's begin here. Okay, we need to try to derive the velocity of point A through the point B and the relative velocity. And again, we can compose the equation. And when we derive the velocity of point D through the point B, we can get more two equations. So let's try to solve that. The relative velocity of point A, when we compose it from the velocity of point B and the relative velocity of A with respect to B. Velocity of point A should be in the x direction and in the y direction, because here it can be moved in the complex, the combined direction, the horizontal and vertical combined direction. But the problem gives the information of the horizontal velocity of point A, but for the y direction is still unknown. For point B, For point B, we know that the velocity of point B have only the horizontal component, and the velocity of A with respect to B, if we consider B as a fixed point and the part ABD just rotate with omega, the relative velocity of A with respect to B is simple. We can predict the direction of the relative velocity. So let's check the direction. Let's check the direction. Of course, the horizontal velocity at point A to the right-hand side is in horizontal direction. Vy, we don't know it's gonna go upward or downward, but let's set positive in the upward direction for Vay. And Vb is to the right-hand side, horizontal direction. Va with respect to B, when we consider B as a fixed point and ABD just rotate with omega, we know that the velocity of A respect to B is perpendicular to the line from A to B, and the angle that it makes with the vertical direction will be equal to this angle. If the line AB is in horizontal direction, the velocity will point upward because it's perpendicular to the line AB. Now line AB has angle theta with the horizontal direction. The velocity A with respect to B, the direction also deviate from the vertical direction by theta. Here's the direction. The magnitude, we know that the Vax is 2 meters per second. Vay still unknown. Vb still unknown. Va with respect to B can be composed in terms of the omega. Multiplied by the radius. The radius means the distance between point A and point B. The radius is 0.1 meter. So for the x direction, on the left-hand side, for the x direction, for the left-hand side we have 2. For the right-hand side in x direction we have Vb, and we have 0.1 omega ABD sine 30 degrees as equation. For the y direction, we have Vay unknown, and we have this in the y direction. And we have the equation here. And let's check the second relationship between point D and point B. The velocity of point D can be composed from VB and the relative velocity of D respect to B. The direction and the magnitude. What is the direction of the VD? Of course, D can run only in the slot in the downward direction. B can run only to the right-hand side or to the left-hand side, but we assume it to be to the right-hand side first. D respect to B. D respect to B is perpendicular to the line from B to D. And the angle here is the same. So the direction of the D with respect to B, it makes theta with the vertical direction. How about the magnitude? We still have the unknown magnitude VD that we need to solve, and VB is also unknown. And the relative velocity can be obtained from the omega multiplied by the radius. The radius is 0.2 meter. So in the x direction, on the left-hand side is 0. On the right-hand side, we have VB and subtract by 0.2 omega ABD sine 30 degree. And for the y direction, we have minus VD. We have 0 and we have minus 0.2 omega ABD cosine 30 degree. And how can we solve the equation? We need to solve this set of equations. We can begin from here. From here, we have VB equal to 0.2 omega ABD sine 30 degree. And we combine these. We substitute VB here. So finally, we have left-hand side 2. On the right-hand side, we have 0.2 plus 0.1. It will be 0.3 omega. And sine. and yes, we can have the omega. We can have the omega. Omega will equal to let me check. It should be, please check the numerical value, but I think it should be correct. We have the magnitude of the omega, and then we need to solve for the VD. We need to solve for the VD. We can put it into this equation. When we know omega, we can solve for VD, and VD will equal to 0.2 cosine 30 degree multiplied by omega ABD. We should be able to confirm the answer by using the ICZV method. Omega is correct, and check the numerical value for VD. You can see that the same problem, you can use ICZV or try to use the translating axis method. And now we learn many tools. After the midterm, we have the absolute method. We have the relative motion method with translating axis. We apply the ICZV if we only want to consider the velocity, not acceleration. The ICZV can be applied only until the velocity step. We cannot get the answer for the acceleration, but in many cases, it's not difficult to obtain the velocity from the relative motion, the translating axis. We may use ICZV to obtain the velocity and then draw the diagram like this again. For the acceleration step, we can apply both methods. Use ICZV to obtain the omega, obtain the V, and then use these two information for the alpha to get the acceleration. We also can do that. And today we study about the rotating axis. And in next week, we will have many examples for the rotating axis. But don't worry, in the exam, I will let you know which method or which technique you need to do. Like we have same picture, same problem. We can solve by multiple way, multiple technique. But in the exam, I will tell you which method you need to use. So that's all for today.
อาจารย์ครับ
ครับ
อาจารย์ครับ are you gonna be, when are you gonna send the recording?
Yes.
Like
when, right?
Yes.
I will receive the notification from Zoom by tonight, and I think I can upload it by tonight.
Okay ครับ
I will notify you in the Line group, in the project Line group that I upload the dynamic record.
Okay
ครับ
thank you ครับ
ครับ
อาจารย์ครับมีคำถามเกี่ยวกับไอโอเมก้า ABD อะครับ
ครับโอเมก้า ABD นี่มันเป็นบทก่อนหรือบทนี้นะ
ไอบทนี้แหละครับ
อันนี้เหรอ
หมายถึงไอเครื่องหมายโอเมก้า ABD อะคือจุดศูนย์กลางนี่คือมัน ABD มันเท่ากันหมดเลยใช่ไหมมันได้คือโอเมก้าเท่ากันเหรอครับ
ใช่ทั้งชิ้นส่วน rigid body ทุกอันจะมีโอเมก้าเท่ากันทั้งชิ้น
อ๋อเราก็เลยใช้กับจะเทียบ A ก็ได้เทียบ B ก็ได้เทียบ D ก็ได้ใช่ไหม
ใช่ขอให้เป็นชิ้นนั้นใช่
อ๋อโอเคครับขอบคุณครับ
ครับ